Alrighty. Hello, my name is Daniel Lunsford, and this is my Physics 2212 Lab 2 Lines of Charge lab report. So for the introduction, the purpose and description of the lab was to use tape in order to observe the transfer of electrons between materials, to calculate a rough estimate of the charge and number of electrons transferred, to produce a more sophisticated and accurate computational model of the two charged tapes exerting a force on each other, and then to use this model to estimate the amount of charge needed to float one piece of tape above the other. And the goal of this lab was to use the data from the lab experiment to simulate the interactions between two charged pieces of tape in a VPython program. So here are some of the Lab 1 models and assumptions. I'll let you read through some of them. For the assumptions, we assumed that air resistance was negligible and that each piece of tape had about the same charge evenly distributed along the length of the tape. So the results and observations of Lab 1, the charged pieces of tape repelled each other. The tape was attracted to both my hand and a neutrally charged book, as well as being attracted to a negatively charged pen. And from there we could assume that the tape was determined to be positively charged. And the calculated charge was 1.344 times 10 to the negative 8 coulombs. Here's some more data and calculations. We've got the mass of the tape, the length of the tape, the width, and the distance between the two pieces of tape, as well as the calculated force of gravity, which was 0.00141715 newtons. And then we could also assume that since forces must be balanced, because the top tape wasn't moving downward, the electric force must be equal to the gravitational force. And here's some data and calculations continued. The charge on the tape as a point charge was 1.344 times 10 to the negative 8 coulombs, and then as a line charge it was 1.9 times 10 to the negative 8 coulombs. So here's my glow script model. On the left we've got the program running itself with the gravitational force vector, the summation of the electric force vectors being the big white one, and then each individual electric force vector along the line of charges. And then down below we've got the four calculated values. The first being the magnitude of the charge as a line of on the tape as a line of charge, and then as a point charge, as well as the electric force and gravitational force. And then on the right we've got the first 40 or so lines of code. Here's my second part of the code. Defining the line of charge, as well as creating the two pieces of tape, which were represented by the little point charges. Here's the third part of my coding. Got the scale factor, the electric force vector scaled, as well as some of the other calculations. And here's the last part of my code, which has all the print stuff, and then creating the arrows on the top and bottom pieces of tape. And then here's some discrepancies and sources of error. So the total charges on each piece of tape are likely not equal. Then some of the sources of error were that these unequal charges on each piece of tape may not have been the same. And then some of the charge on the tape may have been lost due to handling it, as well as the general atmosphere of the classroom playing a role in charge distribution and the observable effects of charged objects. So for the discussion questions, the first one was, what if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So if I had modeled each tape as a single point charge, I would have gotten the following value for the charge on each piece of tape, which was the 1.344 times 10 to the negative 8 coulombs, which is noticeably different from the value I got for the charge on each piece of tape when treating it as a line charge, which was the 1.9 times 10 to the negative 8 coulombs. And then for the second question, why do these estimates differ? And then which value is more likely to be closer to the real value and why? So these estimates likely differ because they're entirely different models. The line charge model applies the superposition principle, and the charge is separated evenly across the surface. And then treating the tape as a line charge is more accurate to how charge is distributed in the world around us, which makes it closer to the real value. And then some of the continued conclusions from Lab 1 were that we can use everyday objects to observe electric interactions, and everything around is sort of participating in the sea of electric exchange, constantly moving toward a desired state of equilibrium. And then I've got my link to my code down below. Thank you.